Hello everyone, I hope you are doing great. Welcome to a new tutorial on how to analyze, visualize, and interpret Likert scale surveys. In this tutorial, I'm going to show you the best ways to analyze Likert scale surveys so as to get the best results for your study, answer your research questions, test your hypotheses, and meet your research objectives. To get started, let's take this example of a Likert scale questionnaire that ranges from 1 to 5, not very like me to very like me. And here we have set of items or Likert scale statements about goal setting. And here we have different dimensions. As you can see, they are in different colors, and each color is a code for each dimension. So we have meaningful learning, we have personal improvement, and we have data-based achievement goals. This questionnaire is adopted from a study by those researchers, and it is used for scientific research and educational purposes, and it is duly cited. So we want to apply it to another context because those researchers applied to their university. We want to apply it, for instance, to our university to see the extent to which this questionnaire, for instance, is valid and to what extent this questionnaire can yield the results. So it has been put as a Google form questionnaire, as you can see. So these are the different Likert scale items. So all of them are made obligatory. So you can just share this questionnaire with students, and then once you get the data, we start analyzing it like this. So once we get the data, we import it to Spaces, and then we can just have this one. So we have this data set, as you can see, so it is imported to Spaces. Then we need to start the analysis. Then we have the first types of hypothesis. As you can see, we have that there is a correlation between the different scales like meaningful learning, personal improvement, and database achievement goals. So here we have the IV or the independent variable, which refers to these three scales, and the dependent variables are the same, okay? Because correlation does not distinguish between IV and DV. And we have as a parametric correlation, we have Pearson correlation, and non-parametric, we have Spearman correlation. Okay, in case we want to test the relationship between different variables. Then, in case we want to see prediction, like we want to have a predictive model to see the extent to which, for example, meaningful learning and personal improvement will predict the achievement of the goals. In this case, we are going to use multiple linear regression because we have two variables. If we have just one variable, we can come up with simple linear regression. And the two variables here, these are the independent variables or predictors, and DV or the independent variable is the outcome variable, okay? And this is the parametric. So the ordinal regression is the non-parametric version of this type of statistic. Okay. To do these two things or two tests on Spaces, we simply go to Spaces, analyze, correlate. So we just need correlate bivariate, and then we need to put the variables to the variable list and check here either Pearson or Spearman. So you can check them both, and this is called sensitivity analysis. Okay, but before getting those variables, you should compute what we call the composite score of each scale. To do this again, we go to transform, compute variables, here statistical, and then mean score, and then you compute the overall mean score for each, let's say, scale or each dimension. Then we can do the same method. Once we finish, we can conduct regression. To conduct a simple or multiple regression, we go to analyze, regression, linear, and we put the IV in the independent list and the DV in the dependent list. The difference between simple and multiple linear regression is simply in the number of the independent variables. If there is just one, this is a simple. If there are many, this is multiple regression. Okay, then these are just the two tests I showed you. If you want to do ordinal logistic regression, you go to analyze, and then you go to regression and choose ordinal logistic regression. So we can choose it from this bar or this icon, or we can choose it from the other menus. So because we have different like utilities, we have different let's say icons here in which we can use also ordinal logistic regression. Okay. So anyways, but just the most straightforward one is this one, because we have the generalized linear model and other models. But not to be confused, let's just stick to the simple procedures for the time being. And I don't want this video to be long. I can make another video in which I will explain this in detail. Just let's say there is no difference in gender. Suppose that we want to test differences in gender, like male and female respondents, in terms of the different goal setting strategies. So the parametric test that can be used is the independent samples t-test, and the non-parametric test is the Mann-Whitney U-test. To run these two tests, we go to analyze, compare means, and then we can check independent samples t-test. And then we put the independent variable and the dependent variable in this list. To run the non-parametric Mann-Whitney U-test, we can just go and check for non-parametric tests, and then independent samples, and then we can just run the test here because we don't have the data, so we can just so here we have the fields. I can just move the gender to the group and the other test to the test fields and click run. Okay, so this is for the Mann-Whitney U test. Then we have the Cross-Wallis H test and the one-way analysis of variance as parametric and non-parametric tests in case we want to test the difference between more than two groups like age, etc. So here we can run the one-way analysis of variance as a parametric test or the Cross-Wallis H test as non-parametric test. To do this on spaces, we go to analyze, compare means, and we go to one-way ANOVA. And then we can just run the age, like for example, the age group is going to be the factor, and the other items or scales will be put in the dependent list. Okay, because age here is a categorical variable that consists of more than two groups. That's why we use the one-way analysis of variance as a parametric test and the Cross-Wallis H test. To do the Cross-Wallis H test, we go to non-parametric tests and we go to legacy dialogues and we go to key independent samples. Okay, so analyze, non-parametric tests, legacy dialogues, key independent samples. And then we can put age as the grouping variable and the scales here in the test variable and choose Cross-Wallis H test, median, etc. Click OK and it will be run. Okay, so these are just the most frequent tests that can be used to analyze Likert scale. They depend on your research hypothesis, your research questions, your research variables, many things. That's why there is no best way to analyze Likert scale. So the best way that is available is the one that you actually create and that you need to have. So it depends on you. So research is a science and an art at the same time. Okay, so as you know, those tests have some assumptions that need to be checked before, because we don't jump to this step running the correlation, regression, t-test, or ANOVA, unless we just check some assumptions. And one of the most important assumption is the fact that the items should be consistent and there should be the reliability test or the Cronbach alpha test before even combining the items together to form a composite scale. We need to run the alpha Cronbach reliability. To do it, we can just go to analyze and then scale and reliability analysis and choose the items of each dimension together and click OK, and then the analysis will be run for the reliability. Okay, then we have the normality test, or before that we have the validity. So the validity of the Likert scales can be measured using the exploratory factor analysis and the confirmatory factor analysis, and it has those analyses have different indices like their MCA, CFI, among others. So these are very advanced techniques, and even the sample size should be greater than 100 respondents. Okay, and it's used for questionnaire validation. To run, for instance, exploratory factor analysis or principal component analysis, so we go to spaces and we go to analyze, dimension reduction, factor, and then we move all the items regardless of the scales, and then we go to extraction, principal components. We can choose a principal access factoring. In case we have just 3 dimensions, we can just choose that. We can choose script plot. We can choose rotation techniques like Varimax, but here I advise you to check the literature to see what has been used. For the scores, we can just display score, and for options, I can just click sort by size, suppress small size that is greater than 30%. And there is another option in which we suppress the even the number of factors here. So we have fixed number of factors. We have just 3 composite scales. So I can just take 3, click continue, and OK. And then the exploratory factor analysis can be run. I can follow the same way and run the confirmatory factor analysis. But this is not valid because I don't have the data. So I can just go to analyze, and I go to spaces AMOS, analysis of moment structure. If you have this software, it will also give you the measurement model and the structural model for structural equation modeling. This is advanced technique to validate e-questionnaire. Okay. Then we have other assumptions like normality. To check normality, we just go to analyze, and then we go to where is it? Go into descriptive statistics and then explore. And we just put all the items in the dependent list, and for plots, we can choose histogram as a visual way to display normality, and normality plots we test to display the numerical measure to see normality. Continue. But mostly in human sciences, the data is not normally distributed. So especially in Likert scale in general. So this is what you expect. Don't worry if you get that. But if you have a larger sample size, that would compensate for it. Another test I would like to show. So in case that the items are not normally distributed, you can apply log transformation. And to do this, you can just go to compute variable and log transformation from here. So you can just find the function of the log transformation in arithmetic. Okay, let's go to ELG, etc. So we have just the log transformation. We can just transform those variables so that they can be analyzed using the parametric tests, for instance, if the data is not normally distributed. What else? Independent variables and regression. So here we have the multi-collinearity correlation coefficients. This assumption can be tested when we are just testing the regression. So when we are using the regression test, we can just choose here collinearity diagnostics, the Darwin-Watson test, for instance. These are assumptions within the procedure. We can do a lot of tests, okay? So you see here, just from these buttons, I can just choose, for example, different statistics. Okay, variance, inflation rate, among other assumptions. So these are all assumptions that need to be checked before actually running the tests. Okay, and this is the correlation coefficients. There are other tests that can be run, like descriptive statistics, frequencies, percentages, mean, standard deviation, median mode, measures of dispersion, etc. So these are all tests that can be used to test your research questions and hypotheses, mostly, especially when you have a Likert scale questionnaire like this. So if you like this video, please give it a thumbs up, and do not forget to subscribe to this channel and share this content if you think is useful, so that I can be encouraged to provide more content like this. and see you soon in another tutorial. Bye for now.